Good morning, everybody. This is Zaina Gordon. I'm the Executive Director for the Fenestration Association of BC. I see we're all just coming on right now. I'll just give a minute or so for everybody to come on, and then we'll get started. Just to advise everybody today, we do have a hard stop at 10:45. Okay, so we're going to get started. I want to be cognizant of everybody's time this morning. Again, good morning, everyone. This is Zaina Gordon. I'm the Executive Director for the Fenestration Association of BC. Today we have with us Edward Lau. Edward Lau is from Leighton Consulting, and Edward is going to provide us an introduction on the new NFRC's program, the new LEAFF methodology. And without further ado, just one thing. If you have any questions, please provide them in the questions box. You can chat amongst yourselves in the chat box if you like, but please provide the questions in the question box. At the end of the session, I will look for the questions and ask them of Eric, and Edward will be pleased to answer them for you. So without further ado, I pass it off to you. Thanks, Edward.
Okay, thanks, Zaina, and welcome everyone to the webinar today. I'd like to thank FENBC for giving me this time slot to kind of present on and introduce the industry to NFRC's new LEAFF methodology for rating the thermal performance of fenestration products. Just a heads up, this is just an introduction, and this is more of an educational kind of webinar, as I don't truly fully see this fully being utilized until maybe in 2022 or 2023. So just a heads up, nothing's changed at the moment. So I'm from Leighton Consulting. We've been thermally modeling with NFRC for product consultations or project-specific thermal modelings since 2009. My current role is in the commercial projects team, overseeing the engineering and the thermal modeling projects, thermal modeling simulations for those projects. So today I'll be going over a quick overview of the current processes, the methodologies and standards, and then we'll dig into LEAFF. What was the motivation from NFRC to create LEAFF? What is LEAFF? And then kind of give an example of a LEAFF methodology and a non-LEAFF methodology and how that differs with each other, and advantages and disadvantages of LEAFF from a simulator's perspective. So the current methodology, when we want to rate a fenestration product for its thermal performance, we would follow the methodologies listed out in NFRC and CSA 8440.2. So these are all the standards that list out the methodologies for simulating and testing procedures of fenestration products to get their U values, solar heat gain coefficients, visual transmittance, condensation resistance, and air leakage. There are some differences between the Canadian and American codes, but there's not much difference. And just remember, these standards are methodologies for rating a fenestration product. These standards don't tell you what U values you require. That's up to the energy codes, local jurisdictions, or the specs of the project. So the current process is, again, this is just a very watered down process of things, how we get our fenestration products thermally certified. So the process of certifying, if you're a manufacturer, you would get your fenestration product simulated and then certified at a certifying body. You would send them your CAD files and a bill of materials so then they can model it properly. If you're selling in the US, you need to also physically test your product for its U value. Now, the process of certifying for the manufacturer does not change with LEAFF. LEAFF really only sort of changes the simulation process. So the current simulation process, for those that don't know, each IGU and frame combination will need its own set of therm models. And one set of therm models is approximately a minimum of 3 models, simulating the head, gem, and sill condition. Once we build all those models, we put them into a program called Window, and then we calculate those total product ratings that we talked about in the previous slide. And those ratings indicate a frame plus IGU rating. For NFRC certification, we have NFRC standard sizes. And we have the sizes on the right on the table, depending on which product types you're simulating and certifying. The purpose of this is so different systems of the same product type can be compared directly. Once you're certified, your NFRC certification lasts for 5 years, and then you'll be put on into an online directory on NFRC's website called the Certified Product Directory, or CPD. Each product will have a CPD number. And just a note here that if you do have a new IGU for the same product, you do need to resimulate and recertify in the current process. So therefore, it could add up to quite a bit of models and quite a bit of CPD numbers because every single combination needs to be simulated. So this is where LEAFF kind of comes into play. So now we get into the new stuff of the simulation process. So the main purpose of LEAFF is really to try to simplify this process and reduce the number of simulations required for the same product with multiple IGU options. NFRC has been working on this for about 10 years now in their RCBC task group. It's currently rebranded to LEAFF. And NFRC has been conducting many, many models to ensure this new methodology is accurate and valid. So let's dig down to it. What is LEAFF? Okay, LEAFF is short for Linear Energy Analysis for Fenestration. It's just a fancy phrase for saying this is a new methodology for rating fenestration products for their thermal performance based on the trend line approach, or line of best fit, or mathematically the line equation y equals mx plus b. This trend line approach is used in lieu of simulating every single IGU and frame combination. Okay, so how do we get a trend line? Well, in order to get a line equation, we should have a minimum of 3 data points, and that's exactly what LEAFF does as well. We simulate 3 IGU options for a specific frame and IGU characteristic, using the worst, mid, and best IGU center of glass U-value options to create that trend line. Characteristics are important. We'll get back to that later. And then after we get the trend line, we can use the trend line to get the total product ratings for other IGU options that were not simulated with the same characteristics based on their center of glass U-values. So we'll go through an example in case that is super confusing. And the last point there, the trend line can also be used to get the condensation index number. So this may be a little different now because the condensation index is not the same number as the condensation resistance. LEAFF methodology only allows for condensation index number. Long story short, the condensation index number versus the condensation resistance number, it's really just another way of calculating condensation of a fenestration product. Higher number, the better, and that's pretty much the same, but it's just a different methodology of calculating that number. So this is an example of a LEAFF trend line chart. Now, the chart doesn't have to look like this. Every simulator or lab can produce something nicer to look at and prettier. But as long as it has all the information, it's okay. So up top, you have the title of the chart, and it lists out all the characteristics of the frame and IGU. The dark blue line that slopes upwards, that is the U-value line. And the colorful lines are the 3 colorful lines that slope down are the condensation index lines. So you notice there's 3 lines. You would only actually use the lowest line for a condensation index. On the bottom, on the x-axis, you have your total product U factor. On the left, you have your total product U factor. Sorry, on the bottom x-axis, you have the center of glass U value. On the left, you have your total product U factor. And on the right, you have your condensation index number. So how do you use the chart? Well, simply you would just input an IGU's center of glass U value. So that was not simulated because the 3 dots you see on the chart indicates those 3 IGUs that were simulated. So the ones that are not simulated with the same characteristics or the same product, you would enter the IGU center of glass U value into the equation that you see here. inside the chart. The X value, you substitute that as the center of glass U value. Do a little bit of algebra. And then once you solve that equation, the answer will become your total product U value rating. You can also obtain your condensation index number by the same manner. You use the center of glass U value. So using the chart is as accurate and valid as if you have simulated it individually. Okay, that's very important because that's the whole purpose of LEAFF. You don't have to simulate every single IGU options. You just enter the IGU center of glass to get your total product ratings. Therefore, the purpose of this is so it's valid for certification. So before we get all excited that, oh, we only need to model 3 things and we can certify anything we want, there are some rules we need to talk about. And this is, I kind of mentioned this a couple of slides before. It's the characteristics, or the trend line characteristics, as NFRC calls them. So these are basically just rules that ensure that the trend line approach, that the LEAFF methodology is as accurate as simulating every single IGU and frame combination. Okay, so essentially each of these characteristics or a combination of characteristics will need its own trend line. Okay, just to ensure that it's as accurate as simulating every single combination. So for example, we have some IGU characteristics and some frame characteristics that we need to consider. So the first one, glass types. So if your products and your IGUs, some have monolithic, some have laminated glass. If you have laminated glass, they have to be on its own trend line. If you only have monolithic, they'll be on its own trend line. If you have double glazed and triple glazed, they'll need to be on separate trend lines as well. If you have different cavity width sizes, you'll also need to put them on different trend lines. If you have interior surface low E coatings, grids and dividers, dynamic glazing like blinds within the IGU, you'll also need its own trend line. For the frame, if you have different spacer bars, different reinforcements, different insulation, or different frame depths, each of those will need its own trend line as well. Okay, so let's go through an example. Fixed window, let's just keep it simple. And let's take a look at what's the difference between LEAFF and the traditional method that we're all used to. So for example, we have a fixed window that's vinyl. 12 different IGUs, no dividers, no steel. We have 2 types of frame. One is insulated and one is not. And we have 2 spacer types, warm edge and a super spacer. If we look closely at the IGU options, you see that there are 2 mil glass. I'm not sure why there's 2 mil, it's just an example from NFRC, but there's 2 mil glass and there's 3 mil glass. But both of them have the same overall IGU thickness. So that obviously means that the 2 mil glass has a different cavity width than the 3 mil glass. Okay, so the non-LEAFF method, traditional, conventional, the thing we're all used to. We have 12 IGUs, so each of those need to be simulated. We have 2 types of frames, one's insulated, one's not, so both of them have to be modeled with all 12 IGUs, and the 2 spacer bars also need to be simulated with all of those as well. So the non-LEAFF method would actually require 12 times 2 times 2, 48 total product simulations. So now let's go to LEAFF. So how does LEAFF help us reduce the number of simulations? Well, so the idea of LEAFF is to get trend lines. So we need to know how many trend lines we actually need, and then multiply by 3 to know how many total product simulations we require. So on this chart, on the left, we list out all the characteristics that would trigger a new trend line. And that's all the stuff we talked about earlier regarding the IGU and frame characteristics. So let's start off at the top. We have glass types. We only have monolithic, so we only need 1 trend line, so we don't need to split that up. We only have double glazed. Again, so because of that, we don't need to split up the trend lines as well. So we're stayed with one. We do have two different cavity width sizes. So that's one of the characteristics that would trigger a new trend line. So now we have to split our one trend line into two trend lines. So 1 times 2 equals 2. So we're left with 2. The next three we don't have, so we will skip those. The grids, the dynamic glazing, and the interior facing low E, so we'll just skip that. So we're still left with 2. We do have 2 spacer bars. So we need to split the 2 trend lines into 2 again. So 2 times 2 equals 4. We don't have steel reinforcing, so we skip the next one. And now the 4 trend lines, we have to split up into 2 again, because we have 1 frame that's insulated and 1 frame that is not insulated. So 4 times 2 equals 8. And we only have 1 type of frame, so we're left in total with 8 trend lines. And because each trend line will need 3 total product simulations, 8 times 3 will equal 24 product simulations. So compared with the non-LEAFF method, that is 50% less models to simulate. All right, so that's all the technical stuff. So what does it really mean for everyone in the industry? So what do we know in the potential timeline? So all the certified simulators of NFRC were trained last year in 2020. And for those that passed the test became LEAFF certified simulators that can perform LEAFF analysis. NFRC is launching the LEAFF pilot program this summer. Minimum of 6 months, but from what I hear, it's expected to last about 12. So if you're interested in participating in the LEAFF pilot program, you can contact NFRC, or I can connect you with someone that is in charge of the program at NFRC. Now, the full implementation date is still to be announced. NFRC's board still needs to decide what that date is, but the intent is to have LEAFF become mandatory after the full implementation date for product lines with more than X IGU options. Now, I put X in there because we still, I believe NFRC and CSA still needs to figure out how many IGU options or above that would trigger this LEAFF methodology. For sure, it's going to be more than 3, because if you don't have more than 3 IGU options for your product line, there's really no point of using LEAFF, just use the traditional method. But whether that number X is 10, 20, or 100, we cannot say yet. NFRC is still working on that. And just know that on the Canadian side of things, NFRC is working with CSA to include the LEAFF methodology into the standard on the Canadian side. So what does it mean for manufacturers right now? Well, nothing really changes today. Like I said, the pilot program is only starting this summer. And anything that's currently certified, non-LEAFF or traditional products, are still certified. You retain that 5-year cycle, but you do have an option during the pilot program to transition to LEAFF if you like. But just note that a product line cannot obtain ratings determined by both traditional method and LEAFF methodology. And we also, in a previous slide, I talked about the condensation index number versus the condensation resistance. Just know that both those numbers can't be on the same label. Again, they pretty much say the same thing. They rate the condensation of a fenestration product, but they cannot be on the same temporary label if you are using CI or CR. So there are more resources here from NFRC's website. These are the official bulletins and announcements and frequently asked questions. So from a simulator's perspective, i.e. My perspective, what are the advantages of LEAFF? Well, from a simulator's perspective, of course, we definitely can reduce the amount of simulations required for certifying a product with many IGU options. That saves a lot of time. And because it saves a lot of time, it potentially can save a lot of money. For manufacturers, you don't need to resimulate for every single new IGU option you like to sell for your product line, provided that it already has a trend line and it has the same IGU and frame characteristics. So potentially you can release products a lot quicker to the market. And of course, charts provide a great way to visualize the product performance. Some disadvantages, well, of course, it's probably only beneficial to bigger manufacturers with lots of IGU options, i.e. more than 3 types, because if you have less than 3 types, there's no point of using the LEAFF methodology. Just use the traditional method, non-LEAFF methodology. And I'll be honest, yes, trendline characteristics and all these rules can be confusing at first. I was confused, of course, when NFRC started training us without telling us what the purpose of LEAFF was. But I believe as we get used to it and we all become educated in the LEAFF methodology, this advantage will essentially disappear. So in conclusion, again, the main purpose of LEAFF is to try to reduce the number of simulations and to simplify the process of certifying fenestration products when compared with the traditional method, non-LEAFF method. Again, LEAFF charts are created using the trend line approach by simulating 3 IGU options. And the trend line example is on the right-hand side picture. And other IGU options within that trend line can get their total product ratings without having to resimulate and recertify, provided that they have the same IGU and frame characteristics that we talked about. And again, the pilot program is expected to start this summer, with the full implementation date still to be announced by the NFRC board. So that is it for the slides that I prepared. So thank you everyone for attending. I guess we do have some time for some questions if anyone does have some questions. And yeah, I'll turn it back to Zaina.
Thank you, Edward. That was a great presentation, very concise, but very well put together. Thank you for your time on that. Just looking here, we do have a question. I can't seem to get it out. Bear with me a minute, sorry.
Okay.
Sometimes technology doesn't want to work with me. So is there a limit to how much the 3 points can vary from the trend line?
So the 3 points, I assume it's the ones that we create. So no, we just need to model the best IGU option, the worst, and the middle one. The middle one being the one closest to the closest to the middle.
Okay, and I do have a hand up from Jagdeep and one from Amy Roberts. I'm going to unmute both of you, then you can just unmute yourselves. Jagdeep, I believe your hand was up first, so if you want to ask your question, you just need to unmute yourself.
Yeah, Zaina, that was my question is sometimes on a data set, the trend line could be significantly different than the individual data points. I was wondering if NFRC has put some kind of deviation limit for the data, but I think Edward has already answered that. So that is good because then you can freely and without worrying about any kind of correlation, just put those 3 points and let Excel do the trend line, and then use that equation in another kind of Excel table to extrapolate for any other IGU configuration. So that actually makes sense. Thanks, Edward. Thanks, Zaina.
So let me add on something. So NFRC says a minimum of 3 data points. You can use more than 3 to get a better line. And there is also a constraint that the R-square number, the statistical numbers of how well all the data points lie within the line, has to be 0.99 or above. And following the trend line characteristics should provide that R-squared number. So to make sure that all the data points pretty much lie on the trend line. So that's
that
why
actually makes sense. Yeah,
no, that's why there's
great.
Characteristics. Yeah.
Okay.
Okay, and the next person with their hand up is Amy Roberts. Amy, I have unmuted you. There you go.
So my question is, does this program only qualify for fabricators who have previously certified so that they know where their worst and highest products fall?
I believe they are opening this up to anybody. in, I believe, the pilot program, and once the full implementation date, they will open it to anyone previously certified or not certified. They want to open it up. So not sure if that answered the question.
Yes, that's good. Thank you.
Yeah.
Okay, are there any other questions? I don't see any more hands up or questions in the Q&A. Oh, there we go, Terry. I knew it. I'm going to unmute you.
I can't help myself, Dana.
Go ahead.
So really interesting, Edward. Thanks for this. And if it's confusing for a simulator, imagine how confusing it is for the layman or the typical manufacturer. So what I'm wondering is, does this, in the data that the manufacturer would then have, does this reduce the amount of small variations in performance, either better or worse? Like, does it come out like kind of an averaging sort of a analysis, or would we still see, these small variations in final performance data based on, small changes in product or glazing?
Sorry, I'm not quite understanding your question.
So what I'm getting at is, if a manufacturer has very small differences in performance, due to some change in either glazing or frame fill or spacer or whatever, you might see some very small improvements or degradation in those numbers. Do we lose any of that really specific performance for every possible design configuration?
Yeah, so if you've changed a little bit, like say you use a new installation or use a new spacer bar, that actually triggers a new trend line. So the only so say you have this trend line, the only way that it would kind of be a shortcut to you is if a manufacturer has used a new IGU that has the same cavity widths, kind of the same characteristics that were the rules that were talked about before. So then we can use that trend line. But if there's any changes to those characteristics, like a new spacer bar, a new insulation, or if you go triple glaze from double glaze, then it will need to be its own trend line. But going back to the performance, this approach is the same as if you were simulating it. So whatever you see now in the degradation or the improvement of those thermal performance, you will see in the trend line as well, because it's as if you've simulated it without actually simulating it.
So without simulating, hundreds of variations of design, you would still have data for all of those different, different low E type or something like that. Would you still see all of those different values?
Yes.
Or do you lose some of that?
So I believe the intent is to use this as a basis first, and then create that table of data. I believe that is the intent of NFRC. I believe this is still a work in progress. Pilot program starting this summer, right? So I think there's still some stuff to iron out, but that would be the intent, to have that performance data visualized and have this trend line as the basis to create that table of data if a manufacturer so desires. Yeah.
Anything they can do to reduce the number of simulations is helpful, as long as you can still retain, all of that data. Even if there's only slight variations in the performance, those are good to have, obviously. So interesting stuff. Thanks a lot.
No problem.
So Edward, we have another question, and then I see Jagdeep's hands back up. So Jagdeep, just give me a minute to ask the other question, and then you can go ahead. So this question is from Navroop Sidhu. It is a high performance triple glazed IG with 2 low E's can have similar U values, but very different SHGC. How is that calculated?
Good question, and I was expecting a SHGC or a visual transmittance question. So there, I guess without going too deep into it, there are 3 numbers that NFRC needs to calculate solar heat gain and visual transmittance. There's a solar heat gain 0, solar heat gain 1, and solar heat gain center of glass. So the 0 and 1 value, the first 2 values, are actually the frame, how the frame performs. And those are the numbers that pertain to the frame. So each trend line will essentially have just we'll have those 2 values, and those will not change based on the IGU. The only thing that would change is the center of glass solar heat gain. So that third number will also need from the window program, and then using the trend line, the 2 values, and then we just plug in the new value that we have for different IGU options, and then we will get the solar heat gain. So the solar heat gain can't be on a line per se. I mean, it can, but it won't be based on the center of glass U value. It will be based on the center of glass HHGC. So hopefully that makes sense.
So Navroop, do you have a follow-up on that? If I'm going to unmute you just in case. So you are unmuted just in case you have a follow-up. Give you a second. There you go.
No, I don't have a follow-up. Thank you.
You're welcome. So Jagdeep, you are unmuted. You can unmute yourself if you have a question.
First of all, Navroop, that was a great question. Thank you for asking that. And Edward, so these 3 data points can just be from thermal simulation and windows. They don't have to have physical test results supporting those numbers, right? Like, we don't have to take these 3 configurations, go to a lab and say how close they are actually to the physical testing. We're just talking about thermal or therm and window simulation, correct?
Yeah, for Canada, yes, that would be valid. I believe if you want to sell your products in the US, I believe you still need to physically test your product. And I'm not sure if it's all 3 or just one of them, but you'd still need to test for minimum one of those 3 data points if you want to sell in the US. Yeah.
Yeah. Okay.
So I don't see any further questions. Does anybody else have a question? Amy, your hand is still up. Do you have another question or are you good?
I am good. I'm so sorry.
That's okay. You're forgiven. No, so I think we're good here. So just so everyone knows, tomorrow you'll receive an email thanking you for participating, and it would also direct you to a link for a recording of this webinar. I want to thank Edward and Taylor. Sorry, I forgot to say that you were online as well. Taylor Wright from Leighton Consulting. Wanted to thank both of you for your time and your efforts in this. And Edward, something tells me that we'll be doing another one in the summer. Or
Probably.
possibly in the middle of the pilot project, just to talk some more and discuss this a little bit further.
For sure.
Okay. Well, thank you, everybody. Please, everybody who's in BC, go out and enjoy this gorgeous day and enjoy it as much as you can. I hope everybody has a great long weekend. I want to thank everybody for their time and look forward to seeing you all again.